Ever heard about the guy who could do, like, crazy calculations in his head? I mean, before he could even talk.
Sounds like someone I should know.
Yeah, you probably do. Carl Friedrich Gauss. They called him the Prince of Math.
Ah, Gauss. Yeah, of
Yeah,
course. A legend.
definitely. And we're going deep into his life today. We've got this academic biography essay all about him, and we're going to trace his path, from his humble beginnings to those groundbreaking discoveries.
Sounds like a fascinating journey.
Oh, it totally is. By the end, you'll see exactly why Gauss is considered like one of the most influential mathematicians ever. So let's rewind the clock. Back to 1777.
Okay, back in time we go.
Gauss is born into this poor family in Germany. But get this, his talent with numbers, it's obvious almost right away. Like, we're talking about a kid who's understanding, like, math concepts, before most kids can even say their ABCs.
Really? That's amazing. Are there any stories about, like, how early this talent showed up?
Oh, tons. There are these anecdotes about him, like, correcting his dad's calculations. I mean, as a toddler, he already had this, like, intuitive sense of arithmetic.
Wow. Must have been something to see.
Right. And then that natural talent, it was just amplified by his curiosity, and that drive to learn on his own. He even taught himself to read.
So impressive. But I bet his father wasn't exactly over the moon about all this intellectual stuff. I mean, back then, a blue-collar worker.
Yeah, you're right. Initially, his dad kind of resisted Gauss's academic leanings. He saw more value in, like, practical trades, which wasn't that unusual back then.
Yeah.
But luckily, one of Gauss's teachers, he saw the potential and convinced his dad to, like, let him keep studying.
That teacher probably changed the course of history, really.
Totally. And speaking of teachers, I have to tell you this classic Gauss story. So he's like 8 years old, right?
Okay, 8 years old, Gauss. What did he get up to?
His teacher, probably hoping for a little peace and quiet, gives the class this super tedious task. Add up all the numbers from 1 to 100, he says.
Oh, yeah, I've heard this one. Setting them up for a long, boring lesson.
Exactly. But while all the other kids are, like, sweating over their calculations, Gauss, he finds a shortcut, like a brilliant insight that lets him solve it almost instantly.
It's like he could see the Matrix or something.
Right. What was his secret?
So instead of adding the numbers one by one, he paired them. 1 plus 100, 2 plus 99, 3 plus 98, and so on. Each pair adds up to 101, and there are 50 pairs.
Oh, I see where this is going.
So the answer is just 50 times 101, which is 5,050.
Boom. Just like that. Not just the speed, but, like, the elegance of that solution. It really shows how different Gauss was, how he saw those patterns and went for the most elegant solution.
Totally. It wasn't just about getting the answer right. It was about seeing the structure, the beauty of the math, that way of thinking. It would guide him his whole life.
So word gets out, right, about this young prodigy. And then enters the Duke of Brunswick, patron of the arts and sciences, sees Gauss's potential, and steps in to support his education.
The Duke, huh? What a lucky break for Gauss.
Oh, it was huge. The Duke provides the financial support for Gauss to go to first the Collegium Carolinum and then this, like, really prestigious university, the University of Göttingen.
Okay, so now he's surrounded by, like, all these other brilliant minds.
Exactly. But even there, Gauss, he stood out. He was great in all sorts of math disciplines, but his real love, it was number theory, arithmetic. Those would become, like, the core of his biggest contributions.
And it was around then he made a discovery that, like, put him in the Math Hall of Fame. I'm talking about the construction of a 17-sided regular polygon.
Wait, hold on. He did that when he was, like, 19?
Yep, 19 years old.
And using only a compass and a straight edge. I thought mathematicians had been trying to do that for centuries.
You're exactly right. Over 2,000 years, people had been searching for ways to construct these polygons. But that 17-sided one, the heptadecagon, it was a mystery. Gauss cracked the code.
So it wasn't just about drawing a shape then. What was so groundbreaking about it?
It's about what he figured out underneath it all. Gauss's solution, it took him deep into analyzing polynomial equations. And that, my friend, would lead him to his doctoral work on the Fundamental Theorem of Algebra. He finished that, by the way, at 22.
Okay, now that's a theorem I kind of remember, but I need a refresher. What does it actually say?
In simple terms, it says every polynomial equation, those with x's to different powers, they have at least one root, a value for x that makes the equation true. Sounds basic, but proving it rigorously, that was huge.
So he wasn't just solving problems, he was, like, establishing math truths. And all this before most people even graduate.
It's wild, right? But there's a twist. Before going all in on math, Gauss seriously considered a career in, get this, philology.
Philology, the study of language, that's like the opposite of math.
Yeah, right? Maybe he saw some connection, like the structure of language and the patterns in math. Who knows? But that polygon discovery, cracking that centuries-old problem, it seems like that sealed the deal for him, for math.
Like he found his true north.
Exactly. And soon after, boom, he publishes his first big work, Disquisitiones Arithmeticae.
Ah, yes, the foundation of modern number theory.
It laid out these like groundbreaking number theory concepts that still have mathematicians geeking out today. So by his early 20s, Gauss, he's a math rock star, but his story, it doesn't stop there. His interests, they expanded. He reached for the stars, literally. And that's where we get into his astronomy work, where he did some pretty important stuff for how we understand the cosmos.
Okay, let's talk about space then. I know he had a big impact there too.
Right. In 1801, he became really famous for rediscovering the asteroid Ceres.
Rediscover. What happened to Ceres? Does it get lost or something?
Well, astronomers, they had seen it, but then they, lost track of it. Lots of people were trying to find it again, but it was Gauss, with his math skills, who managed to do it.
Okay, but how do you use math to find a missing asteroid? It's
Yeah.
not exactly hiding behind a planet or something.
This is where Gauss's genius really shines. He came up with this statistical technique called the method of least squares. He used it to analyze the, little bits of data they had and then calculate Ceres's orbit.
So he predicted where it would show up again based
Right.
on how it moved before.
Exactly. And that method, it's not just for astronomy anymore. It's like a basic tool in data analysis now. Everything from economics to engineering. It helps us model trends, make predictions, get real information from data.
Wow, so something that started as a way to find a lost asteroid is now helping us understand the stock market and the weather.
Yep. That's the thing with Gauss. His ideas, they had these huge ripple effects, impacting fields he might not have even thought of. But hold on, let's not get ahead of ourselves. At this point, Gauss, he's still working as an assistant to the Duke, hoping for a job that'll let him really dig into research.
Right, he was still kind of under the Duke's wing, so did he eventually find that dream job?
Not really. He gets involved in this Challenge of Hanover, a big project from 1818 to 1832, all about geodesy and surveying.
Geodesy. I'm not sure I know what that is.
It's basically the science of measuring and understanding the Earth, like its shape, size, gravity, all that. And Gauss, he made huge leaps in this field.
Yeah.
Always curious, always wanting to be super precise.
So from space objects to mapping the Earth. Quite a change.
Seems like it, right? But remember, Gauss was always looking for how to use math in the real world. And this project let him combine his theories with actual observations.
And that's where he invented the heliotrope, right? That thing that used sunlight to, make long-distance surveying more accurate.
Exactly. The heliotrope, it lets surveyors measure over huge distances, way more accurately than before, and it shows another side of Gauss. He wasn't afraid to get his hands dirty to make practical solutions.
So not just a theoretical genius, but an inventor too.
Absolutely. And his inventions, they went beyond gadgets. Remember those doubts he had about Euclidean geometry? Well, those led him down a path that would change how we see space itself.
Oh yeah, we definitely need to explore that more. But before we do, let's talk about another chapter. His collaboration with Wilhelm Weber in the 1830s. Another brilliant scientist. They teamed up.
Yeah, that was a period of intense research focused on the mysteries of terrestrial magnetism. And you know what? That work led to some amazing discoveries, eventually even the first electric telegraph.
Wait, the telegraph? Like the granddaddy of the telephone and the internet. Gauss had something to do with that.
Oh, yeah. Their work on magnetism helped them understand how to send electrical signals across long distances. That was the foundation for the whole communication revolution that followed. And there's more. Gauss's work with magnetism led him to develop the concept of potential theory. It's this mathematical framework that goes way beyond just magnets.
Okay, so we're talking about a true scientific polymath here. Mapping the Earth, understanding magnetism, laying the groundwork for how we communicate today. It's mind-blowing how much Gauss influenced the world we live in.
It really is. But amidst all these achievements, we got to remember, Gauss was a complex guy, a man of contradictions. His personal life was far from simple.
All right, let's talk about the man behind the math then. What was Gauss like?
Well, he was known to be a bit of a loner, preferred his own thoughts and calculations over parties and stuff. He did have a few close friends, though, like his relationship with Wolfgang Bolyai, another brilliant mathematician.
Ah, the drama of genius friendships. What was their story?
Well, they were tight because of math, their shared love for geometry, but their views clashed on some fundamental ideas, especially non-Euclidean geometry. It shows that even brilliant minds can disagree on, really basic
Oop.
principles.
Brilliant mind, a complex personality, and a life full of these amazing discoveries.
Hmm.
It's no wonder he's considered a giant in science. But before we get too deep into that, let's take a step back and really explore those revolutionary ideas that shook the foundations of geometry itself.
Yeah, let's dive into non-Euclidean geometry. The world where parallel lines can meet and triangles don't always add up to 180 degrees. It's mind-bending stuff.
So we've talked about Gauss being this math whiz,
Mm.
changing astronomy, mapping, even helping invent the telegraph. But now let's get into something that really sets him apart. His willingness to, question the very basics of geometry, stuff that had been considered absolute truth for centuries.
You mean his work on non-Euclidean geometry, right? That's some seriously mind-bending stuff.
Exactly. I mean, we all learned the Euclidean geometry in school. Parallel lines never meet. Triangles always add up to 180 degrees. It seemed like, the bedrock of math. So what made Gauss start questioning those rules?
Well, you see, he was so deep into understanding curvature and he was obsessed with making sure math was super rigorous. That led him to explore other geometries, systems where those familiar rules, they didn't have to be true.
So he was saying there could be other types of geometry, other ways to understand space itself.
Exactly. Imagine the surface of a sphere. On that curve, those Euclidean rules, they kind of fall apart. Parallel lines, they can actually meet,
Hmm.
and a triangle's angles, they can add up to more than 180 degrees.
Okay, now my head's spinning a little. So it's like different geometries for different shapes, different spaces.
That's a great way to think about it. Gauss realized that Euclidean geometry, it works great on flat surfaces, but it wasn't the only way to describe space. And that opened up a whole new world of math with implications that went way beyond just geometry.
Now, if Gauss had these, radical ideas about non-Euclidean geometry, why didn't he shout it from the rooftops? Why not publish it right away?
Ah, that's where we see another side of Gauss. The guy was incredibly cautious, super meticulous. He wouldn't publish anything until he was absolutely sure. And remember, back then, these ideas were totally revolutionary. He was probably worried about getting slammed by the scientific community. Everyone was so stuck on Euclidean thinking.
So he kept it quiet, almost like a secret project. I can't imagine having a discovery like that and not telling anyone. Do you think, keeping it secret, did it hurt or help math in the long run?
That's a good question. Historians of math still debate it. Some say if he'd published sooner, maybe non-Euclidean geometry and its uses in physics would have developed faster. Others say his caution let those ideas, mature before they hit the world.
It's interesting to think about how one decision can, change the course of history, the paths not taken.
Yeah.
But even though he didn't publish right away, his idea still had a huge impact, right?
Absolutely. His letters to other mathematicians, guys like his friend Wolfgang Bolyai, show that he was definitely talking about these concepts. And it was through those conversations that others, like Bolyai's son Janos and this Russian mathematician Lobachevsky, they came up with their own versions of non-Euclidean geometry and actually published them.
So it's like he planted the seeds, even if he didn't see the full bloom, so to speak.
Exactly. And the impact of those ideas was massive. Non-Euclidean geometries, they changed how we understand space and curvature. They even became essential for Einstein's theory of general relativity, the one that describes gravity as curved space-time. It's a huge shift in how we think.
So from an abstract math concept to, a fundamental principle of the universe, that's quite a legacy. It makes you wonder, what other revolutionary ideas are out there, just waiting to be discovered, waiting to change everything we think we know?
It's exciting to think about, right? And it brings us back to what makes Gauss so fascinating. He wasn't just some guy who crunched numbers. He was a visionary, not afraid to challenge the norm, to explore the unknown, to push the boundaries of what we understand.
And that's what drives scientific progress, right?
Yeah.
That willingness to question, to doubt, to venture into the unknown. Now, we've talked a lot about Gauss's life, his work in math, astronomy, physics, but there's one thing we need to explore more: his posthumous discoveries. What can you tell us about the stuff they found in his unpublished notes?
Oh, yeah, it's like he left behind a time capsule full of brilliant ideas. After he died in 1855, they went through his unpublished manuscripts and found all these groundbreaking concepts, many of them way ahead of their time.
Like a secret stash of math secrets. What were some of the most amazing things they found?
Well, there were advances in number theory, more work on elliptic functions, and even some early explorations of ideas that would later become central to topology. That branch of math that studies how shapes stay the same, even when you stretch or twist them. It's crazy how much he was able to figure out in one lifetime.
Makes you wonder, what if he'd been more open about sharing his work while he was alive? Could he have sped up math and science even more?
It's a thought, isn't it? But maybe there's something to be said for the surprise, the delayed gratification of finding hidden genius. Those posthumous discoveries, they just add to his legend. They show how deep and wide his mind was.
Like he left behind a bunch of puzzles for future generations to solve.
I like that. And his work, it still inspires and challenges mathematicians and scientists today. There's so much to learn from his writings, connections to make, problems to solve, using the groundwork he laid. His legacy is still shaping how we see the world.
So we have Carl Friedrich Gauss, the Prince of Math, a man who not only solved tough problems, but redefined what math is and how it connects to the universe. His story shows us the power of curiosity, the importance of being rigorous, and the impact a brilliant mind can have.
Well said. And I think it's important to remember that Gauss's legacy goes beyond his specific discoveries. It's about how he approached knowledge, how he relentlessly searched for truth, and his willingness to challenge what everyone thought they knew. Those are qualities we can all learn from, no matter what we study.
It's about holding on to that childlike wonder, that thirst for knowledge, that drive to figure out the world's mysteries. And I think anyone who's ever been amazed by the beauty and power of math can connect with that.
Absolutely. So as we wrap up our deep dive into Carl Friedrich Gauss, I think it's worth remembering how deeply he changed how we understand the universe. Mapping the Earth, figuring out magnetism, setting the stage for modern communication, his contributions are just incredible.
And besides the practical stuff, there's something really inspiring about how willing he was to question, to doubt, to explore the unknown. It reminds us that real innovation often comes from challenging the status quo, from pushing past the limits of what we think we know.
Exactly. Gauss's journey reminds us that learning is an adventure, and there's always something new to find, a different perspective to consider, another layer to uncover. And maybe most importantly, he shows us that even the most established ideas can be challenged, leading to amazing progress.
So, to wrap up our look at Gauss's legacy, we'll leave you with this thought. What unshakable truths are you taking for granted in your life or your work? What assumptions might be holding you back? Maybe it's time to channel your inner Gauss, embrace the power of doubt, and see where it takes you. You might surprise yourself. It's really amazing, when you think about it, Gauss's work, it's like his influence reaches so far beyond those specific formulas and theorems.
Oh, for sure. I mean, we've talked about astronomy, surveying, even the telegraph, right? But the thing is, Gauss, he wasn't just about getting the right answer. He was about building a whole new way of thinking.
So it's not just what he discovered, but like how he did it and why, right?
Yeah, exactly. His legacy is as much about how he approached knowledge, his incredible attention to detail, his rigor, that never-ending curiosity. That stuff goes way beyond any one subject. You can see his influence in how we approach science today, how we solve problems.
Makes you wonder what he'd think about the world now. All this data we have, these computers that could do like 1,000,000 calculations in a second. It's almost like he saw this coming.
It's an interesting thought. Remember, Gauss was working back when you had to do calculations by hand, like super tedious stuff. And yet he comes up with this method, the method of least squares, that's now essential in this whole data-driven world we live in. That just shows how powerful his insights were.
And speaking of powerful insights, we can't forget about those posthumous discoveries, right? It's like this final act of brilliance, leaving behind all these treasures to be discovered after he was gone.
I know, right? It's wild. Imagine that, a lifetime of groundbreaking work, and he still had so much more to offer. Those notes and manuscripts he left behind, they showed a mind that was always pushing the limits, exploring ideas that people wouldn't even grasp for decades.
Give us a peek into those hidden ideas of Gauss. What kind of stuff are we talking about?
Well, there's some seriously advanced number theory stuff, further developments in those elliptic functions he worked on, even early explorations of ideas that would become the foundation of topology. That's a whole branch of math that deals with the properties of shapes, even when you stretch or twist them. It's mind-blowing.
It's like he was playing four-dimensional chess, years ahead of everyone else.
Yeah. That's a perfect analogy.
Yeah.
And that's what's so amazing about studying Gauss. There's always this feeling of discovery, of uncovering layers of insight that we might not even fully understand today. He's a challenge and an inspiration for anyone who loves math and science.
Okay, so for someone listening who maybe isn't a mathematician but loves learning new things, why should they care about Gauss? What's the takeaway?
I think it comes down to this. Gauss's story shows us that the human mind, it has no limits when it comes to understanding. He proved that even those ideas that seem totally set in stone, they can be challenged and changed, and that leads to incredible advances in knowledge.
It's that spirit of questioning, that drive to find the truth that's so powerful. It reminds us to never stop learning, never stop being curious, because who knows what amazing discoveries are still waiting out there, just waiting for us to find them.
I couldn't agree more. And maybe the most important thing Gauss left us with is this. He showed us what the human mind is truly capable of, and that inspires us to reach for that same level of brilliance, whatever we're passionate about.
Beautifully said. And on that note, we'll leave you with this thought. What about you? What unshakable truths are you taking for granted in your life, your work? What assumptions might be holding you back? Maybe it's time to be a little more like Gauss, embrace that power of doubt, and see where it takes you. You might just surprise yourself.